Hello and welcome. We are very grateful to all of you for giving us your time today. I want to give a big thank you to Sandra Hall for all of her work organizing this webinar. We are very excited to tell you about our newest product, the AQSync. In this webinar, we will talk about the evolution of the AQSync, its components, and some of its uses. You will also be hearing from Michael Ogletree from the City of Denver about our partnerships and pilot programs. Before we dive into the AQSync, I want to give you a brief history of our company and the story behind the development of the AQSync. Here at 2B Technologies, we are obsessed with miniaturizing air pollution instruments and making them easier to deploy in remote environments. We started 20 years ago with ozone. The top two monitors pictured are the instruments we developed to be much smaller and less power hungry than the traditional ozone monitor on the bottom. But we don't compromise on data quality. All of the miniaturized ozone monitors we have designed are designated Federal Equivalent Methods, or FEMs. To be designated an FEM, the instrument has to go through rigorous tests to prove the accuracy of its measurements. After selling our ozone monitors to researchers and various agencies around the world, 2B Tech wanted to start a hands-on educational program to teach students about ground-level ozone. The Global Ozone Project, or GO3 project, was born from this idea 12 years ago when I was hired. In the GO3 project, we sent ozone monitors to schools around the world, and the students' data were automatically uploaded and displayed on Google Earth. After running the GO3 project for 5 years, at 100 schools in 26 countries, we overwhelmingly heard from students and teachers that they wanted to measure more pollutants and wanted to take their measurements mobile. That was only really possible to do on a large scale with sensors. As an instrumentation company, we were well aware of the limitations of sensors. So we gathered up the best performing sensors to make a sensor suite called the Personal Air Monitor, or PAM. The PAM became the centerpiece of our next educational program, AQTrex, with development funded by the National Institutes of Health. We kept PAM data quality high by instituting a rental model, and we perform a calibration check before sending the PAM to a school. We also added a feature in the AQTrex app that compared PAM data side by side with data from the nearest reference station, along with its location. This way, PAM users can do a calibration of the PAM by walking by a reference station. Our experience with the PAM and AQTrex really began to illuminate the need for a community calibration station, especially for communities with no reference station. Since we make FEM instrumentation for ozone and NOx, we decided to package those instruments together, add high-quality measurements for the other pollutants, and the AQSync was born. The AQSync is the best of the best in one package. It was developed under a grant from the National Science Foundation and combines 2B Tech's ozone and NOx instruments with the best of other manufacturers' measurement techniques, taking into account data quality, price, power consumption, size, and weight. The following video we put together for you provides a great summary of the features of the AQSync. After the video, I will go through each of the AQSync's main components.
Revolutionize your air quality monitoring with the AQSync. Developed by 2B Technologies, the AQSync Air Quality Monitoring Station provides FEM quality measurements for ozone and nitrogen dioxide, along with proven monitoring techniques for measuring nitric oxide, carbon monoxide, particulate matter, carbon dioxide, and volatile organic compounds. The AQSync also provides measurements of meteorological parameters such as temperature, atmospheric pressure, relative humidity, wind speed, and wind direction. The AQSync brings together the best of the best instruments and sensors in the most compact, affordable, power-stingy air monitoring station available on the market today. Data are uploaded to the cloud, using either cellular or Wi-Fi for easy access from anywhere in the world. Encased in a weatherproof enclosure, the AQSync can be deployed for almost any application. For instance, it's ideal for ambient air monitoring near roadways and industrial sources of pollution. Because of its advanced measurement techniques, the AQSync serves as the perfect replacement for a traditional and much more costly regulatory monitoring station. Here they're compared side by side. The data from the AQSync correlates well with data gathered from the regulatory monitoring station. The AQSync's reliable data at an affordable price make it possible for communities, schools, and businesses to accurately monitor air pollution and protect health and safety.
Bruce Randolph was one of our first set of schools that we were looking at in terms of the Love My Air program. And through collaborations with the Colorado Department of Public Health and Environment, they were interested in working with us, specifically at Bruce Randolph, to look at different transportation patterns through pickup and drop-off to improve air quality. And an AQSync, having reference grade measurements, allows us to place one of those at Bruce Randolph and then very closely be able to measure the impact of changes in transportation to local air quality.
The AQSync is easy to install. Changing its location to monitor in different areas is a breeze. The low power requirements make it possible to provide power with your battery or solar panel. And it can be operated remotely. The AQSync was also developed to be an on-the-go calibration station for mobile sensors.
I think it's important when you're thinking about low-cost sensors and mobile mapping, how can we keep the data quality high? So through this pilot, we'll be doing, daily, sometimes, multi-times during the day, co-locations with these AQSyncs to be able to do calibrations on the fly and make sure the data quality is collected as accurately as possible and updated frequently.
Calibrations are accomplished by co-locating a mobile sensor with the AQSync for a short period of time. During the calibration process, data from both the mobile sensor and the AQSync are uploaded to the cloud. Then, the calibration parameters associated with the AQSync are applied to the mobile sensor. This provides the sensor with an on-the-go calibration that will improve the quality of data that it collects.
AQSync allows us to have reference grade measurements and help calibrate and better make use of low-cost sensor networks.
Contact the 2B Technologies team to discuss using the AQSync for your next monitoring project. Use this revolutionary air monitoring station to take your air quality measurements to the next level.
Out of many, one. Let's briefly go over the components we chose for the AQSync. Ozone is measured using a 2B Tech FEM ozone monitor and uses the fundamental principle of UV light absorption. Nitrogen dioxide is measured using a 2B Tech FEM direct measurement of NO2 by absorbance. Nitric oxide is measured by converting NO to NO2, and the converted NO2 is measured by direct absorbance. We use the MET1 AQ mass profiler for particulate measurements. The AQ mass profiler is an optical particle counter that detects single particles between 0.3 and 10 microns in diameter. Aerosols are sampled into the profiler through a total suspended particulates inlet, which is heated during periods of high humidity. We chose the PP Systems CO2 gas analyzer to measure CO2, which uses the measurement principle of non-dispersive infrared absorbance, or NDIR. Carbon monoxide is measured using an AlphaSense electrochemical sensor. Temperature, relative humidity, pressure, and wind speed and direction are measured with an RM Young weather station. Winds are measured using a 2D sonic anemometer. That completes the major components of the AQSync. We continue to evaluate other additions to the AQSync, including a total VOC measurement. With its high-quality measurements, the AQSync is perfect for countries or U.S. locations that don't have a regulatory site. The AQSync can also provide anchoring measurements for sensor networks by serving as a calibration station. The AQSync can also be used as a walk-by, drive-by, or park-by calibration station. We are currently collaborating with the City of Denver to evaluate the use of the AQSyncs as a calibration station for PAMs installed on trash trucks. In the pictures, you can see the PAM mounted to the trash truck and the AQSync installed at the trash truck parking location. While parked, the data from the AQSync are used to calibrate data from the PAM in the cloud. You can barely make out the driver in that picture, but it's Donnie Cruz, the operations manager for the City of Denver. I'd like to take a moment to give him a huge thank you. In person, I would have requested a round of applause. None of this work would be possible without his support and assistance. We wanted to interview him for this webinar, but he was too busy overseeing the operation of 2,000 pieces of moving equipment in Denver. Hopefully at some point you can hear his perspective on supporting mobile monitoring on city fleets. Next, you will hear more from Michael Ogletree about this pilot project and other projects using the AQSync in Denver.
Yeah, so there are a couple of programs we have within the City and County of Denver, including the Love My Air program, where we're measuring air quality at schools to be able to take those measurements and allow community members to be able to use that information to make informed decisions about their exposure to air quality and different mitigating opportunities they have to limit adding to that pollution. In addition to that, we're also kind of looking at different project-specific mitigation strategies. So, for example, there's major highway reconstructions that are going on in the City and County of Denver, and being able to measure that information in real time allows us the opportunity to address that while it's happening instead of afterwards. I think the AQSync, it meets this very specific need. So, with the advent of low-cost sensors, they're proliferating around cities. And then they have, a lot of the reference instruments as well. But how do we work as a city to kind of fill in the gaps without building an entire new air monitoring station? So the AQSync allows us to have reference-grade measurements to help fill in the gaps and help calibrate and better make use of low-cost sensor networks. Right now in the City and County of Denver, we have 2 sites that have ozone. We are in a severe non-attainment area for ozone. And with the AQSyncs having an FEM ozone monitor in there as well as FEM NOx, it allows us to kind of use those additional devices, the AQSyncs, to be able to put them around the Denver metro area and identify ozone precursors as well as ozone concentrations to better inform how we can address regional issues. Having the opportunity to pilot some of the mobile mapping here in Denver allowed us to think through a good amount of strategies for filling in the gaps where stationary sites such as sensors or reference or other AQSyncs may not be able to meet all of these, right? So kind of looking at how can we fill in the gaps and maybe sometimes even in disproportionately impacted or environmental justice communities. So having them equipped on vehicles that have indiscriminate mapping. So things like garbage trucks that are, there's garbage trucks, garbage exists everywhere throughout the city. So how can we put it on these routes that kind of hit the different points? And then in terms of the data piece, I think it's important when you're thinking about low-cost sensors and mobile mapping, how can we keep the data quality high? So through this pilot, we'll be doing, daily, sometimes, multi-times during the day, co-locations with these AQSyncs to be able to do calibrations on the fly and make sure the data quality is collected as accurately as possible and updated frequently. To be most effective, I think if we have them where they park and along their routes. So we have one down at the Central Platte station, which is where they come in the is where they park at the end of the day and where they leave from in the morning. So having one there allows us for longer term co-located calibrations, and then one along their route. So we can also test out, if while they're driving around, let's say, something happens meteorologically that would impact their readings, be able to have, a station or a location where they could calibrate during the day as well. And then, like I said, at the end of the night, they'll go there and they'll calibrate again.
As an extension of the efforts Michael described, we are also excited to announce our new grant from NIH, funded to explore the value of hybrid monitoring networks. We will use AQSyncs as anchors for PAM sensor measurements and Love My Air for education and engagement programming in the effort to establish best practices for designing stationary and mobile hybrid air monitoring networks. We are collaborating with the City of Denver, TD Environmental Services, and Montrose Environmental on this project. Be sure to come see us and the AQSync in person at the 2022 ASIC conference in May. We will also be submitting presentation abstracts to summarize the outcomes of all of this amazing work. We can't wait to meet all of you. Thank you so much for giving us your time today. We would also like to thank NIH and NSF for their support of these exciting projects. I welcome you to reach out to us to discuss your monitoring needs and goals. We would love to work with you to design a network that makes the most sense for your unique situation. Now we will take some questions that Hayden Opperman has queued up from the chat.